All right, today we want to do a quick review. First of all, the individual that created the Cartesian coordinate system was Rene Descartes. He invented the Cartesian coordinate planes, which we've shortened down now to coordinate planes. Remember, coordinate planes is your x and y axis, with your horizontal line being your x-axis, your vertical being your y, and we have the origin, which is the intersecting point. Then we have 4 quadrants within here, quadrant 1, 2, 3, and 4. Now, within that coordinate plane, we can come up with points, which we usually represent by ordered pairs. The ordered pairs are using my x values and my y values to locate that point. Now, in that, we start talking about relations. Relations is a set of ordered pairs. Within that, we have the domain, which is the x value, and the range, which is the y value. Now, there was 4 ways to show a relation. One was our ordered pairs, mapping, those are the ovals, graphs, using our coordinate system, and our tables. So now I want you to answer a few questions for me. First, a blank is a set of ordered pairs. Okay, that is a relation. Blank is the first number in the ordered pair. That is either the x value or the domain. Blank is the second number in the ordered pair. That is your range or your y value. Okay, I want you now to list me the domain of this relation. My domain would be 0, 10, 20, and 30. Remember, your domain is all of your x values. Now list me the range. The range here would be 9.1, 6.7, 10.7, and 13.2. How do we determine if a relation is a function? Remember, a relation is a special relation, which is called a function, and that is where each domain only has one range value. So each x only goes to one y. Okay, so at this point, if you look at all of my names, which are my domains, they are only going to one y apiece. Okay, now if you notice, I have a range here that 2 of my domains go to. That is okay. All right, it's only when my domain goes to 2 different ranges that it is not a function. Okay, again, function is a set of ordered pairs that has each input giving exactly one output. So I want you to tell me, is this a function? Yes, this is a function. None of my x's go to multiple y's. Is this a function? No, it's not, because I have a 5 that goes to a 3, and I have a 5 that goes to a -6. So therefore, it is not a function. And the last one, is that a function? Yes, that is a function. All of your x's only goes to one y. It does not matter that I have 2 y's. It matters if my x goes to 2 different numbers. Determine whether this relation is a function. Yes, it's a function. Determine if this relation is a function. No, it is not a function, because 6 is going to 1 and 6 is pairing up with 2. Now, what we're going to do today is we're going to take our functions and go toward graphing. Okay, so what's going to happen is you're going to get an equation. Okay, and at this point, I want you to create a table to give me 5 ordered pairs. So we're going to make our table here. So in my table, you need to set it up with my x variable first. Then I want my equation here. So 2x plus 1 Then I want you to list my Y. Then I want you to list me your ordered pair. So this is going to be the standard table for every time you do this. The only thing that's going to change is this right here, because you're going to put your new equation in each time. Now, so here I would like 5 points. I would like for you to use -2, -1, 0, 1, and 2. Now, I'll tell you, sometimes there's going to be special circumstances that we will get away from those types of numbers, but for right now, those are the numbers that I want. So what you're going to do is you're going to take this equation and substitute in your different values of x. So the first time through, you're going to plug in a -2. And then you're going to do the math. So 2 times -2 is -4. -4 plus 1 is -3. Now your ordered pair is your x and then your y. So -2, -3. I'm going to do it again, but this time I'm going to plug in the next number down, which is my -1. So 2 times -1 is -2. -2 plus 1 is -1. So now my point is -1, -1. Now I have 2 times 0. That's 0 plus 1. So my ordered pair is 0, 1. Then I'm going to have plug in the 1. When I solve it, I get 3. So I have 1, 3. Now I have plug it in 2. I would get 5. Now at this point, I have taken my function. I have created a table which has given me a relation with the ordered pairs. Now you're going to graph. So you will have graph paper, but we're going to freehand this one. So I'm just going to put some little marks here to help me with my spacing in a moment. Remember, when you're graphing points, you always start at your origin. We're going to go to -2, -3. Let's go back to my origin. I have -1, -1, 0, 1, 1, 3, and 2, 5. Now if you notice, that kind of looks like a straight line. So I'm just going to use my line right here. I will draw it, and then I'm going to put arrows on each end, and I'm going to label that line the original equation. So y is equal to 2x plus 1. Okay, everybody see what I did there? Okay, let's look at another one. If I gave you the equation y equals 5x minus 5, again, we're going to make our table. So here's our x value. Here's my equation. Okay, then we have our y value, and then we have our ordered pair. Now we're going to plug in our numbers -2, -1, 0, 1, and 2. Okay, at this point when I plug in, I want you to tell me in the example what I get for y. So I get -15. All right, now we're going to plug in -1. So 5 times -1. Go ahead and do that. It's going to be -10. Plug in my 0. It's -5. Plug in my 1. Plug in my 2. And those are my ordered pairs. Then we would go to our graph, and we would graph. Now, this was going up to 15, so I may not have enough room on my graph paper to show the -15. So if so, I can omit that one, only because It's so big. Now, if multiple problems were big, what I might want to do is I might want to count instead of going 1, 2, 3, 4, 5. I might want to count by 2, so it would be like 2, 4, 6. So even if I had a 1, I could go halfway in between. If that was 0 and 2, we know 1's going to be in between. So I could still do that, but it would give me a little bit more room to put my numbers on, okay? So we're just going to go ahead and create our numbers. You would have a grid paper. So the first one we said was -2, -15, so that would be somewhere down here. Then we have -110. I have 0, -5. I have 1, 0. And I have 2, 5. And then I will draw my line. And do not forget to label that line with the equation that you have. Okay. Now, the special circumstances I had mentioned earlier was if I have a fraction here, okay, the only time that I might want you to change your values in our table that we use, instead of -2, because if I multiply 1/3 times -2, I'm going to get another fraction. So what I'm going to do is I'm going to take multiples of this bottom number. That way, I'm going to end up with whole numbers. So here, I might use -6, -3, 0, 3, and a +6. That way, when I multiply 1/3 times -6 minus 1, remember, I want to make that a fraction. So this looks like -6/3, which is actually -2 minus 1. So that would actually be -3 as an answer, and then I would do my ordered pair. Okay, I kind of shortchanged you on our table here, just so I could show you that multiple of my denominator. Okay, so if you have a fraction, what I would change my numbers here to my multiples of my denominator. That way I end up with a whole number here instead of either another fraction or a decimal. Okay.